how to enter presentation.
So whenever you're ready, you can go ahead and.
Yeah, I think it's fine. Okay, just like this. You just angle it. Yes, I want to enter presentation mode. Try F11 and then fix. No. Do you know how to enter full screen on here for the presentation? I'll try this button. The play. Where? That's down right next to the right here.
Are you in?
Over there.
There you go.
There we go.
And now, I'm just getting a white screen on my Zoom though, just so you know.
No.
So I don't know if you're sharing your screen or if you're sharing per application, but it doesn't.
That fix it?
Yes.
All right, so I'm Harris. This is Eddie, and we'll be presenting on version control, specifically Git. Okay, we'll be going through the agenda first. First things first, we'll be going over the importance of version control and the best practices, then advanced branching strategies, merging techniques, rebasing, resolving conflicts, advanced Git commands and techniques, best practices and pitfalls, and then we could also go through interactive tutorials. Now, first, let me just give off a brief historical introduction to make sure that we know that, these were tools made by real people. So Git was first founded in 2005 by Linus Torvalds, and it was originally made to manage the development of the Linux kernel. And GitHub was founded in 2008 by Tom Preston Warner, Chris Wenstrath, and PJ Hiet, and it's built to make Git more accessible. Now, Git and GitHub, what are they? Well, Git is used to track changes in source code or any files over time, and it runs locally on your machine. And GitHub is a web platform for hosting Git repositories, and it's online and accessible from anywhere, used for collaboration and management. And I just wanted to point this out because this was confusing when I first started learning version control a while ago. Git and GitHub are not the same thing. Git is the underlying control system, and GitHub helps make that system more accessible. So a basic setup just in case, for those who have their laptops, or for those who have their laptops or personal laptops, whether it's Mac or Windows, you could open the terminal or the command prompt and just type in git -- version just to see if you have Git installed. I'm pretty sure you do, but just in case. And you could also, for those who haven't made a GitHub account, you could make it one right now. And optional, which this could be really useful, you could also download Github Desktop. It's very convenient and simple to use. It basically has the core functions of a lot of the stuff we go over. But just to make sure y'all know that we'll be working through the command line interface through this lecture. We'll be going over commands that you'll use directly through for Git in this lecture. So GitHub Desktop is not a replacement for these for Git entirely, but it's something that makes Git more accessible and easier to use. So first, let me just go over the GitHub fundamentals very quick. So before we go over Git, a basic setup, creating a repository through GitHub, it can be created either through GitHub website or the GitHub Desktop app, and it can also be created through Git. And there's also an option of cloning a repository through GitHub, because we have to remember this is just a website, a web app that hosts Git repositories. That's the main reason. That's the core function of GitHub. And we have this concept of forking. It's being able to copy a repository for your own, that is your own personal copy of the repository that doesn't affect the main repository at all. It's making changes through your own repository of the Git project. And this is how people make contributions towards open source projects. You would copy the repository to your own computer. You'd have your own personal repository, and you could make You could either make changes to contribute towards an open source project. You could make a pull request to see if your changes would be approved or not. And there's also just the ability to make changes for personal use. Maybe you just want to copy this repository and being able to just mess around with it or make changes on your own for your own personal device. And there's also certain permissions you could give to people, such as the read access type. People that can only copy or read in from your repository. This is a write access type where people can write to the repository, make changes. There's the admin, which can do, which has a lot of control over the repository. There's the maintainer, which is also something that we participate in with the capstone in GitHub, which has which is access type for a specific repository, and there's a collaborator which can also read and write. Now, let me just go over GitHub Desktop right quick since I mentioned it earlier, and it's something that's really accessible. It's something that's really convenient. Here's a quick overview. GitHub Desktop is a GUI that simplifies using Git, making it easier to do the core functions of Git, such as committing, pushing, pulling, and branching without needing to type in any commands. GitHub Desktop is not a complete replacement to Git, as I said earlier, as it lacks more advanced features that we'll be going over in this workshop, such as cherry picking. I could also pull up the GitHub Desktop app just to show y'all the interface. See right here. Dr. Ted, do you see it on Zoom, GitHub Desktop?
Yes.
Okay, so just to go over here, this is a desktop tutorial, a repository. This is how GitHub Desktop looks like when it's installed in your device. You can see right here, like we've gone over, like also the documentation team has gone over. You can make comments about what exactly you're trying to push into the repository. You could give a description, a summary. You could commit it before completely pushing it to the repository. There's a history, which is easily accessible. You could see all the history of the repository, all the changes that were made. You could see right here. You could fetch origin, so you could pull or push anything that's going to the repository. And also you can make a new repository, add local clone repositories. And I just wanted to point out, when you're making a new repository, this could be done through Git or GitHub Desktop. There's something called the Git ignore. And I think it's really important. Like one example is when I was trying to make a game in Unity a long time ago, and I was collaborating with people in this, I guess, in Xbox Game Camp. It was in high school a while ago. And we're collaborating through GitHub, and there was this little accident that happened. We never actually did a git ignore in anything. So every time we try to push or pull any changes that we made, it would be this huge file, and we didn't know exactly what we were doing. I was just learning version control then, but it's really important that you do this at the start of your um, project. But yeah, that's GitHub Desktop. It's just really easy to use, and it's something that's could be nice as a beginner. Here. Okay, so you go back to the slide.
All right, so let's cover the Git fundamentals again. So a repository is a project's directory which contains all of the files and the entire history of changes that were made in that repository. And it's basically your central hub for version control. A working directory is the current state of your project files on your local machine, and it will be where you make these changes to the files prior to staging those changes. And then the staging area is a temporary area where you can prepare changes for the next commit. This will allow you to review and control what you will be including in your commits. So let's cover these basic commands that most of us probably already know. We have git init, which will initialize a brand new Git repository. And then we have the clone command, which will clone a repository that already exists onto your local machine. We have git add. This is where you can stage the changes that are ready to be committed. We have git commit-m, which is saving the stage changes with a descriptive message. So basically here we're just saying what changes we made in a very descriptive manner, which we will get into later. Git push, which will upload our commits to a remote repository. Git pull, which fetches and merges changes from a remote repository. And then Git status, you can basically check the status of your working directory and staging area to see what's actually included, what's not included. And then Git log, which just shows you the commit history. So why is version control important? So the three reasons why it's really important to learn and get really good at version control is because it enhances collaboration, it maintains the integrity of our code, and it will streamline our workflow. So how does it enhance collaboration? It allows for multiple developers to work simultaneously without the risk of overriding each other's changes. And then it also allows us to track what changes were made, when they were made, who made them, why did they make them, which is basically every change is recorded with who made it and why. It also provides us with the ability to commit code reviews, which will facilitate reviewing code changes prior to them being merged and ensuring that everything is up to date with our standards and is working properly. Because we don't want to just be the only person reviewing the code. We want fresh eyes to look at it and make sure that it's functioning well. It maintains code integrity, again, through version history. It allows you to revert to previous versions. Say we're making a calculator app, somebody adds a function to do addition, but they don't account for integer overflow. So we want to make sure if they push that we're able to revert and so on and so on. And it also helps in resolving conflicts, which we will get into later, where we can have merge conflicts where people are editing the same file in different branches. And it streamlines workflow by managing different versions and releases in an efficient manner. It has continuous integration and continuous development support, which a tech workshop will be presented on in the future about. And then branching strategies. This will allow us to organize work through branches that are for different features, different hotfixes. And it's just a great way to organize our repository. So some best practices when you're submitting code. We want to make sure we have descriptive commit messages. Normally, where we might be used to working on a project by ourselves, where we can just make abbreviations, make something, and we assume ourselves to know that. But now we're working with multiple people, multiple teams. We want to make sure we have standards, and we want to make sure these commit messages are as descriptive as. We want to clearly explain what changes we made in this commit, and we also want to give motivation as to why we made these changes. So one example is instead of a commit message saying add validation, you should update it to be add validation for user email input to prevent SQL injection. You see the differences there. It's much more descriptive, and whoever's reviewing the code, whoever's looking at the history, they have a better understanding of what's happening and why it's happening. We always want to use commands such as fix, add, update. There are even many more that we'll get into. And we want to make sure these are consistent. We don't want one person using one version of commit messages, one kind of like example. So example would be like adopting a team standard. We want a component, we want to action. And then there's an example, UI, update navbar styling. This will make this will facilitate code reviews faster. It will be easier to look at our history, look at what changes are made. So basically everybody will be on the same page at this point. And then we want to make sure we have frequent commits. The last thing you want to do is write 2,000 lines of code, go to submit it, and you have a bunch of resolutions that you need to solve. And we want to commit small and logical chunks of work. Out there in the real world, a lot of companies, they advocate small PRs. They don't want 1,000 lines of code being submitted because this will take forever to review. You don't want your manager spending a day reviewing your code. Nobody wants that. So, for example, we want to commit after completing a function or method and testing it. We don't want to go add 10 functions, submit them, and then leave them up for review. And this will also allow for easier reverts in the future in case our master branch runs into a problem. So we can revert a single commit that introduced a bug without overriding other changes that we made. And this also provides for better tracking, as I said before, because it enhances our ability to track progress and identify any issues that arise. And we want to make sure our branches are always updated. You don't want to get into, you don't want to start working on a file, work on a file for 3-4 days without doing pull requests. My advice would be to pull as frequently as you can, always pull. And this will make sure that our branch is always current and up to date. And then, yeah, it will minimize the risk of merge conflicts and it'll ensure smoother integration of our work with the team's efforts. So let's get into some dangers of improper Git usage. The 3 dangers are merge conflicts, the risk of overwriting work, and losing code and history. So merge conflicts, they take a lot of time to resolve usually. And resolving conflicts, they're oftentimes time consuming and frustrating. We don't want to spend our entire workday trying to resolve a conflict that we could have prevented in the first place by using proper standards of version control. And it also risks a bug. So we have 2,000 lines here, we have 1,000 lines here. We're trying to merge them and resolve these conflicts. We may mess something else up in the process of doing this. Just like we might be able to, for example, we might overwrite work. Be careful using git push force, as this can erase other people's commits. And we want to make sure that we're pulling these changes because failing to pull latest changes will cause conflicts. It most definitely will all the time. If you're working on a file for 3 days and you haven't pulled, there's like an 80% chance that it's going to result in a conflict because somebody else may be working on that file too. And this again will result in lost code and history.
Okay, so now we'll go over to, you've been mentioning branching and branching, so let's go over branching, introduction to branching. What is a branch? It's an independent line of development, and its purpose allows isolated development without affecting the main code base. Now let's go over the benefits of branching. Isolated development, safely develop features or fixes, such as working on a new login feature without impacting the existing login system. It also gives a parallel workflow. Multiple branches enable simultaneous work, different teams working on front end and back end simultaneously, and simplified merging, easier integration of changes when ready, such as merging a completed feature branch back into main. So Git Flow, the branch roles, we could go over the roles that what exactly happens when you're doing branches. There's the main branch, which is the production ready code. It's something that Harris mentioned. You should always be pulling from, and it's essentially the main branch where of the project. And then there's the integration. There's the develop role, which is the integration branch for development. Then we have our supporting branches, the feature branch, which is created from develop. We have release branches, prepare for production releases, which prepare for production releases. We have the hotfix branches, which are immediate fixes to the main branch. And we have guidelines that we use, such as the stable main, which keeps main clean and which keeps the main branch. I like to say when I'm mentioning main, it's the main branch, which keeps the main branch clean and deployable. We have pull requests, which use for merging to facilitate reviews. And another guideline is consistent workflow, following the model to ensure team alignment. And a use case and example is coordinating multiple releases with overlapping development cycles in a large project.
Yeah, so basically Git Flow is a strategy on how we are going to incorporate these branches into our workflow. And after this, we'll dive into another type of strategy, which is trunk-based development. So a trunk-based development is we have a single branch. We don't have a develop branch as well, but all developers will commit to main or trunk. And we use feature flags in order to enable or disable features. So some advantages of trunk-based development over Git Flow is there's less merging complexity because we have shorter lived branches. And then it's ideal in environments that are using constant integration because it promotes frequent commits and testing. But some considerations is that trunk-based development requires heavy discipline. This is a model that's usually used when you have a lot of senior engineers on a team and not a lot of junior engineers. It needs robust testing and code reviews. And another consideration would be its potential instability, because direct commits to the main branch can introduce issues if everything is not properly managed. So the use case when you want to use trunk-based development is in rapid development environments where continuous deployment is practiced. And here we have kind of a graph to depict the changes, differences between trunk-based development and Git Flow. Does anybody spot any differences that they want to mention?
Our branches, Git Flow.
Yeah, longer branches in Git Flow. You see how we have a developed branch and it's leading to where we're developing our features. And in trunk-based, we have these shorter lived branches. And the reason for that is because we're committing to main or trunk frequently. So who thinks that the trunk-based development model would be better for our class and project? Okay, I agree. We don't want to commit to main or trunk frequently at all. We want to use pull requests and integrate code reviews, and we want to follow this model.
So now we'll go over some commands in terms of creating and managing branches. We have the list branches, which is just simple git branch. We have create and switch, which is git checkout -b, and then branch name. We have switch branches, which is git checkout, branch name, delete branches, git branch, dash. Well, the most important thing is that we make sure we remember the concepts of what exactly branching is. These commands, you don't expect, neither me or Harris expect you to memorize them. There's something that you could always reference either through cheat sheets or through the slides that we'll be posting in the Git repositories. But they'll be here. And if you ever need any help, you can ask me or Harris. So let's move on to the next slide. Here's a branching tutorial Harris made about that will show some examples.
Okay, so we're doing first, we have a simple calculator class here. We have an initial commit with our addition method. And now our stakeholders, they want a subtract method. I don't know why, but they want a subtract method added. So let's develop the subtract method using branching. Ignore the typos, there's a lot of that reason. So we're in our repository. We're going to use this is an issue right here. We're committing our first. Remember what we emphasized earlier and other tech shops emphasized, we want specific commit messages to describe what we're doing. So we're describing this as our initial commit. We're adding the calculator with additional functionality. Okay, so we've committed those changes. So now we're creating a new branch for this new feature, which we want to add, which is subtracting. So we're going to check out and create a new branch using git checkout -q feature /subtract. Notice the name. We want it to be very specific. We're creating a feature, and what's the feature? Subtracting. We're going to go ahead and create our back subtraction method here. Go ahead and add some login. Now we're done with this feature. We haven't really tested it as we should, but we will do that in the real world environment. Now we're going to go ahead and see these changes at calculator.java. Now we're going to commit this using the same thing model as before as subtraction functionality. Okay, now we've added that. Now we're gonna do a git log to see our git status. So now we're gonna get a graph representation of what our git log looks like. Okay, look into the next slide. Okay, so here I just wanted to point out. Okay, so right now, we're gonna go ahead and check out master. You'll see on the bottom, our branch will tell us that we are now in master. It's treated down there. The master, that's how you can tell which branch you currently are on. Now we're gonna look back and see it's drag functionality we put it in there. I'm gonna go back to our feature cycle track this subtraction method is there, and you can see on the bottom that we are now in feature steps track as well. If you go to the page, you go to actually look at graph, so we can see that we have our origin master at the bottom, and then we have this new branch on top of it, and clicking on it, you can see the initial commit, which changes that were made, then the feature slash track the change that we have here as well. Command line using git log online graph, or you can just look at it in the source control panel, which may be easier as it is a better depiction. Okay. So now, after checking out those commands we have our initial graph on the left and our goal one on the right. Does anyone want to take a guess on how we can go from the left to the right using our git commands? There's 2 lines. I'll give you a hint. Anyone? No, we're not merging just yet. But good guess though. So first we want to create this new branch, don't we? So how can we create and switch to a new branch? What command would that be? Get, yep, new image, right? And then we'll have that new image there and we'll be on new image now. So how do we get it to drop one level down? It's not a branch command specifically, it's just a regular command. Commit. Yep. Do a git commit. And that'll take us from the left to the right. And these graphics are actually from a resource that we'll recommend to y'all later, which is Learn Git Branching. It's a great resource. That's literally how I got a good idea of version control myself.
Okay, so we'll go over now the best practices in branching. I'd just like to point out that, it doesn't have to be like a complicated project. You can do something simple as a calculator and still see these concepts such as branching, any concepts in version control. And it's important just being able to practice these commands, reinforce these concepts. And as it'll be useful as it's hard to retain things without exposure to it. So now we'll go over this slide. So number 1, use descriptive branch names. As we mentioned before, it's really important to be descriptive. You want to make sure that you have something that is able to describe exactly what you're doing. An example would be feature/user authentication, bug fix, login error. It's straightforward. It's explaining exactly what you've done. And then we have another point, clarity indicates the purpose of the branch. Like I said, you want to make sure you're very straightforward, you're very clear, you're very exact in what you've done. And it's something that has effect that's outside of code, that's outside of program, that's an important thing. First, as Harris mentioned, such as code reviews, such as your manager, making sure you don't want your manager to take up too much time reviewing your code. Number 2, we have regularly sync with the main branch. We want to make sure we pull frequently to make sure there's no, we avoid conflicts, we avoid merge conflicts. and as mentioned as in the other point, conflict minimization. Now we can go on to our third point, limit the branch lifespan, frequent merges, merge back to main. When tasks are complete, you want to make sure you merge frequently. You want to avoid drift, keep branches from diverging too much. As we mentioned before, and as we keep mentioning, it's important to uh, keep make sure to keep pulling and keep merging branches, make sure they don't diverge too much. Number four, we avoid long-lived branches. We want to make sure to avoid integration issues. Long-lived branches increase merge complexity. And as in a lot of computer science classes, we want to make sure we avoid too much complexity in our code and things even like version control. We want to avoid stale code, risk of code becoming outdated. And number five, here's a use case, an example, merging feature branches into the develop branch after each sprint to keep integration smooth. Now, let's start with what exactly is merging? We've been talking about it. It's combining changes from one branch into another. It integrates different lines of development. It's important because it helps with collaboration. It merges individual contributions. It it helps incorporate new features into the main code base, and it ensures everyone is working with the latest code. This is a core function of Git. This is why we're using Git. It's to be able to have it's to be able to collaborate more easily. And here's another use case, an example. It's bringing a completed and tested feature into the main branch for release. So now let's go over fast forward merging. Fast forward merging moves the branch pointer forward to the latest commit. It occurs when there are no divergent commits between branches. Characteristics would be when the history remains linear, and it's easier to follow. And a command example is git merge feature branch. And the use case would be fast forward merging a small update when no other changes have occurred. Now we'll go over recursive merging. The definition for that would be a standard merge, creating a new merge commit. It's used when branches have diverged. Characteristics would be it preserves history, it keeps the individual commits, and it records the merge event. A command example would be git merge feature branch, and a use case would be merging a feature branch into main after both have new commits. And now we'll go over squash merging. Squash merging combines all commits from a branch into a single commit. It merges into main while keeping history clean. And advantages for squash merging, it it helps with a simplified history. It reduces clutter from multiple commits, and it's easier to revert a feature if needed. A command feature, git merge, squash feature branch. It's followed by git commit, another command. And the use case would be merging a branch with many micro commits into a single commit for clarity.
Okay, so let's get some participation here again. So one of these depicts a squash merge, and one of these depicts a standard merge. Who thinks the first one is a squash merge? Anyone? Who thinks it's a standard merge? Okay, yeah, perfect. So as you can see here, we just displayed it. So squash merge, we have these three branches that have many different commits. So we're gonna squash those into one commit, put it here. And as you can see, that's what we were talking about. It keeps a very linear history compared to a standard merge, which depicts like that, where we have our features and creating a new loop and we're pushing in there. So that's much easier to view, but again, they both have their own purposes. So here we have the pull requests. So we can see here as well on GitHub, we can check out our branches. So here we have our master branch, which has our initial commit. And then if we go there, we have our subtract feature that we added here. Now we're gonna go ahead and merge these. So first we want to make sure we do a push request, which I think is depicted in this video on both branches. So then we can just do it there, but instead we want to go to the pull request. We want to create a new pull request. We select our branches here to compare. And we select our master and then we can bring feature slash subtract with it. Here we can see changes. So we'll go ahead and create that pull request. We want to make sure we add a descriptive description here. Whenever we are submitting PRs, we want to be as descriptive as possible without over describing. We want to still keep some abstraction there. So here we're just saying we added intensive subtraction functionality here. I'm not assigning any reviewers, but normally, like in our pods, you can assign your other two pod mates to review your code, which is essential. Don't push code without review, please. And you can assign all the class here. I'm just assigning it to myself. So normally Git says this merge automatically. There's no conflicts that we have to resolve here. We will simulate one where we do all conflict in the future. We'll simply just go merge our pull request and we'll commit our merge. Okay, so it tells us our pull request is fully merged and closed. And now it also gives us the option to delete this branch, which is what we should do because we want to avoid long lived branches. It's served. You can go. So here again, after we're going back into that repository, we're going to go ahead and we're going to switch back to master from our feature branch. And here we want to make sure we pull again, we pull these changes we just made, or else if I go back and start working on code and submit it, we're going to have a merge conflict. And then there you can see the Git log graph there, where we have our initial commit at the bottom. We have our feature branch, our feature subtract branch, where we added our subtraction functionality. And then there we can see our merge pull request. It tells us where it was from, and we can see that we have completed the merge, and it looks just like that graph we looked at earlier. So that would be a standard merge or a squash merge. Standard, yep. Okay, here we go again. So here on the left, we just have a main branch. We want to create a new branch. We want to merge it. Any idea how we can accomplish this? It's kind of similar to the last one. No need to overthink it.
Check out.
Okay, so that'll be our first command. Yep, we're gonna go git checkout -v bug fix. Okay, so now we've created that, and now kind of similar to the last one. So now we have that branch. What do we want to do with it? We want to make a commit, right? Because we can't merge without creating that commit first. So we'll go ahead and make that commit. So now it looks like that graph we had previously, but now we also want to add a feature to main or add a commit there. So how can we do that? So right now we're currently on our bug fix branch. You see the star on main there, the star is on bug fix, and we end up with a star on main. So what's that kind of giving you a hint to do here? Not merge yet, because we want to go back to main and make a commit as well, and then merge it, right? So how can we do that? Okay, yep, we'll go get checkout main, and then we will do what there, create a commit. I think I heard somebody say that. We'll create a commit, and then what can we finally do? Yep, we'll merge bug fix. So boom, there you go. And it seems confusing at first with the graphs and everything, but once you really start looking at it, it's kind of the same thing as before, and we're just adding another commit and we're just merging it. So good job. Yeah.
I guess I'm a bit confused on why we need to go back to the main after creating that bug fix and commit before we can merge the bug.
So
You answer that question, restate the question so it gets fixed.
okay, so what was the question again?
I'm a bit confused on why we have to go back to the main branch and then commit before we can do that.
Okay, so why we have to go back to the main branch and commit before finally merging? It's just because of the way we have there we only have two commits there. So the way this is we have another commit on main. We want to move main further down. So that's the reason why we do it, and then we'll merge it. Yeah. So you see how before we start with two commits and we end with 5. So this is the other commit we're creating on main, the commit we're creating on bug fix. Because first when you create it, bug fix will just end up here. It'll just be there on C1 as well. So we're creating that new commit and we're dropping it down there. And then we're going to switch back to main and drop a commit there. Then once we're there, we can merge and we'll create that.
So in that second graph, just to make sure I'm listening right, say the C3 circle or node or wherever we've gone. We wouldn't move the git commit because it'll basically C4 and then we.
That would be the merge right there. Yeah, exactly.
Okay, so now we could go over best practices in merging. Number one is always to review before merging. We make sure we ensure code is tested and meets standards. And we make sure to review changes always. You use pull requests for peer reviews. As shown, we want to make sure we add reviewers before making any pull requests. And number two, we communicate changes. We make sure to notify our team. We inform others about significant merges. We want to make sure, for those who paid attention during the documentation workshop, we use detailed commit messages, and we're mentioning it right here. We want to make sure we're clear and all the messages that we sent that we're giving the exact purpose. And we want to make sure we don't, as mentioned before, we don't just wait to make a commit. We want to be able to commit frequently. And number three, resolve conflicts early. We want to merge often. We want to incorporate changes from the main regularly to avoid conflicts. And we want to be proactive. We want to address conflicts before merging. And number four, we want to document merge decisions. We want to make commit messages that explain the reasons for the merges. And we want to have merge policies that follow team guidelines. These are things that are really important outside of just programming that we have to understand. It's really important that we know this as a team. And number five, a use case and example is scheduling merges during low traffic periods to minimize disruption.
And the reason why we keep on saying pull frequently, so another thing that relates to that is you don't want to work on multiple files over multiple days, because the more files you work on, the higher chance is that somebody else is working on that file. Because most likely than not, we're not going to have enough files for everybody just working one. But we want to minimize the time we spend on multiple files, because it's just going to make it more complex for you, because these files are most likely going to have changes in those 2 days. And then you have 3 files that need to resolve merge conflicts, which again, it takes a lot of time that we could just simply avoid by following this best practice.
Now we could go towards understanding rebasing. New topic. What is rebasing? It moves your branch to a new base commit and it reapplies commits on top of another branch. And benefits to this are it creates a clean straight line history and it simplifies logs. It's easier to follow to project progression. And then it shows before and after diagrams of branch histories. And an example of rebasing is updating your feature branch with the latest main changes before merging. So let's go over interactive rebasing. Its purpose is to edit, reorder, squash, or drop commits. It cleans up your commit history before sharing. Command for rebase is git rebase -i head n, where n is the number of commits. Options for rebasing is to pick, to keep the commit as is, rework, change the commit message, edit, amend the commit, squash, combine with previous commits, and drop, remove the commit. And a use case, an example for interactive rebasing is combining several work in progress commits into a single meaningful commit.
So here we have an interactive rebasing tutorial. I wasn't planning on including this, but I kept on messing up in the tutorial so much where I had to drop commits. Well, to the point where I was like, let's just show how this works. So here we're basically gonna drop a commit. So we're gonna use our function here, rebase -i, and now we define the commit hash. And the way of doing this is to just go over here and copy our commit ID. We don't want or anything. We want to commit hash. So one way you can get the commit hash is through the source control graph, or you can also get it using the Git log. And we're going to use we want to drop the topmost commit. So we're not going to copy that one. We're going to go ahead and copy the commit ID of the one that comes before it. So that's what we're doing here. Oh my gosh. So the dash I make sure it's the interactive rebase, and then once we apply the command, we'll see what happens next. So when we go ahead and copy it, and so this opens up a Vim editor, and we can decide the order of our files. Everything we see our topmost one is there, and it's only that one. So we're gonna go ahead and change the pick to a drop, showing that we want to drop this commit. So we're gonna go ahead and change that to the drop, make sure we save our file, and as soon as we open it, you see that commit was dropped. So rebasing versus merge. Let's go over the pros and cons of each. So for rebasing, the pros is you have a cleaner linear history. It's not going to be as complicated as merging is, where go from here to here to here to here. It will be very linear. We'll show an example of that, which results in an easier navigating ability. So the cons is that it will rewrite your history, which is not ideal for branches that are shared. For merging, the pros is that it preserves the complete history, and it's very safe for public branches. And the cons is that it can create a complex history with many merge commits. So they have kind of opposite pros and cons. So once you use rebase will be for private branches prior to sharing those branches. And for merge will be for integrating branches that are shared.
Okay, now we can go over the best practices in rebasing, but I just want to add a point. It's just all these things such as rebasing and branches, they all have their use case. They're all just a tool in a toolbox that we can all use. And it's just like, to give an example, maybe like data structures. There's a toolbox that we have, and they all have their own specific use cases. They all have their moments where they shine the best. And that's why it's important to go over all of them. So now the best practices in rebasing. Number one, do not rebase shared branches to avoid rewriting history others depend on. And we also want to use interactive rebase to clean up, to tidy commits before pushing. We want to force push carefully, use git push, force with lease to prevent overwriting others' work. And we want to communicate with the team to inform team members when rebasing and force pushing.
We have another rebasing tutorial. So here we got another request from a shareholder. Apparently they want a division branch now. We're going to go ahead and create this new branch, get checkout dashboard. We should be getting more comfortable with that. So now we've switched and created the user/divide branch. So let's go ahead and add a simple division method. Add it to our log. Make sure we log it as well. Now, instead of merging this, we're going to use rebase, and we'll see how commit history differs. We're going to go ahead and stage these changes. Go ahead and create a commit again with a descriptive commit message. And we'll keep on emphasizing that. It's very important. We're going to go ahead and say that we added our division functionality here. Boom, we have that. And now we're going to go ahead, check out our master branch. So you can see our master branch that we're getting that it does not exist. You can go ahead and add a segment figure as well that we're performing the subtraction. Now we're going to go ahead and stage these changes as well. This branch. Edit as well. Okay, so you always see we added a not for a long here. Go ahead. Switch back to our division branch here. Okay, that one doesn't have those track logging as we can see. Now we're going to go ahead and replace it main. Master, that's why I didn't have Peter as a boom. You can see that we have our track method there, and you can see the linear history. History is linear, it's not like the merge request where it's depicted on the bottom. So we've gone ahead and add that functionality to there through a simple rebase. Okay, so we have another one of these fun graphs. So we're starting again with the same start state. That's our goal state. So how can we accomplish this without merging, but and rebase? It's very similar to the other ones again. So let's start by creating our bug fix branch, right? So git checkout -b bug fix. We're gonna go ahead and do that. What's next? Anyone wants to take a guess? Committing, yes, perfect. There we go. So we've committed, and now what are we gonna do? We're gonna check out main, and then from there, yep, make a commit, and then anybody else wants to give it a shot? Check out bug fix. And then what was this tutorial about? What are we gonna do? We're gonna rebase it. Yep, exactly. There you go. And you can see here, same thing as the other one, but we're changing the rebase to a merge, and look at the difference in the graph. As you can tell, the other one was diverging. It was a little confusing to look at, right? But this one, we have a straight linear history, which is what rebase will provide to us.
Now we can go over detecting conflicts. When exactly do conflicts occur? It's during merging or rebasing when changes overlap. Conflict indicators could be Git reports conflicting files. Files contain conflict markers. And a scenario, a use case would be two developers modify the same lines in a file on different branches. So manual conflict resolution. Here's some steps to resolve. Would be to open the conflicting file, decide which changes to keep, and remove conflict markers. We could use Visual Studio Code, built-in merge conflict tool, and it gives us options to accept current, incoming, or both changes. And after we resolve the conflict, we could stage the file, git add. We could use the command git add a file to continue the merge or rebase. So now we can go over the best practices for conflict resolution. Number one, communicate with the team, coordinate on overlapping work. Communication is going to be really important. We could resolve conflicts promptly, avoid leaving conflicts unresolved. We can understand the changes, review both versions carefully, and we could test after merging, ensuring code functions correctly.
So I know other groups have covered this, resolving a merge conflict. Does anyone here feel uncomfortable with resolving a merge conflict? Because if you are, we can continue ahead with this tutorial. If not, I don't want to make it too repetitive and teach y'all something y'all already know. So let's use a share of hands. Who feels comfortable resolving a merge conflict? All right, tutorial it is. Full screen. All right, so here we're just gonna create another feature. We're creating a multiply feature because apparently we need that in a calculator as well. So we're gonna go here and we're gonna add. Uh, we're just gonna change the line of code up here. Add method. We made this one -1. Now we're gonna switch back to a branch. We're gonna change this to. And so this is, of course, very trivial. It's not really creating a regular merge conflict. Now we're gonna multiply feature. I'm gonna add this change that we made, and as you can see, the add method we added -1. You keep note of that. That's what's gonna cause this for conflict. So now we're gonna go ahead and create this message. So we added our multiplication functionality. We're going to go ahead and check out our master branch again, and here we're going to make the conflicting change that will also cause the branch conflict. We're going to go here and we're just going to add a plus. Okay, cool. We got that. We're going to go ahead and make these changes, stage these changes as well. Now we're going to go ahead and try to merge this feature. When we go that, we can see right here that we have conflict here in our feature slash multiply. We have -1, but there we have a +1. So normally when it's not the same line, Git's smart enough to figure out and solve the conflict itself. But the reason why we put on the same line is to make sure that we have to manually resolve this. So we'll go here. We can see that our head has that change, and so now we're opening up VS Code. We can just resolve this conflict here. So here we'll have some tools to either changes from each side or there. We're just going to set the changes from feature side multiply. Or we can variable base. We're just going to go ahead and set those changes and say that we don't want to set these changes. So we're not going to do anything there. So that means that we've accepted the changes from multiply, but not the ones from our master branch. So if we do that, we accept those changes, we can see that boom, we have -1 instead of +1 because -1 is what we put and will be accepted. So now after doing that, we'll just simply add and commit these changes, and then that's it. Then we can even write a commit saying that we resolved this merge conflict. Right. So now we're going to get into some more advanced features, which what we've covered before is 90% of what you need. This is just the extra 10% that can make your workflow even better and even faster and even more efficient. So what is cherry picking? Cherry picking basically applies from one branch to another branch. And then the use case for this usually is to apply one hotfix to multiple branches. This way we don't have to copy and paste our code every time. Do that, we can just simply use cherry picking to apply it to all these branches. And we can also use this to select specific features without merging the entire branch. So the command for this will just be simply git cherry pick, and we're going to use our commit hash here, just like we did in interactive rebasing. So a scenario where you'd use this is, again, applying the critical fix from the develop branch onto the release branch. And here we have the it's such a tutorial. We're going to have another one of those graphs. So here we're going to create a new feature. And it's going to be a hotfix stored by feature. So we're going to check this out, create it. Save these changes as well. Message. So all we did, we added a state divided by 0. Okay, go and make the changes. We can see them up there. Now we're going to copy this and check. We're going to check the So here's the graph. When we have a regular hotfix, we added a state divided. Now we're going to go ahead and check out now we have these cherry pick commands that get that connected without actually values. We'll go ahead and share it there. We have our commit ID, same way back and forth. Don't see out there that in your history will apply there without adding purge or without having rebase. Okay, so it looks complicated. It's one command. So we have this graph on the left, and this is our goal here on the right. Don't overthink it. Look at the difference here. What are we trying to add? What are we trying to cherry pick? We're just going to use our cherry pick command here, nothing else. We're going to use our cherry pick command to take us from that to that.
We're trying to cherry pick that C3 node, so that works.
Yeah, yeah. What else?
C4.
C4. What else? C7, right? C3, C4, C7. That's the command right there. Get cherry pick C3, C4, C7. That takes us from that to that. Again, this is a more advanced command. It's not really essential to know, but it can help in certain situations.
Now we could go over stashing. I'll try to be a little bit more quick since we're running low on time. So the purpose of stashing, temporarily save uncommitted changes. It cleans working directory without committing. Some commands are git stash, which saves current changes, git stash list, which it's for viewing saved stashes, git stash apply the fastest apply the latest stash, and git stash pop, apply and remove the latest stash. Some use cases would be for switching branches without committing, pulling updates that affect your current work, and a scenario would be causing current work to address a high priority bug on another branch. So some best practices with advanced commands, cherry picking, as we went over, is to avoid overusing to prevent complex history. Be cautious of, also remember to be cautious of dependencies between commits. We have stashing, which name stashes for clarity. Remember to apply or drop stashes. We have some general advice to give. We understand the impacts of these commands and we regularly review and clean up stashes. The scenario that we could give is periodically clearing old stashes to avoid confusion. So a recap of best practices just to review what we've gone over before, commit guidelines. As we keep saying, we want to use clear and concise messages. We want to commit logically group changes, and we want to avoid large monolithic commits. We also have some best practices for branch management. We want to have consistent naming conventions, and we want branches to be focused on single features or fixes. We want to be able to make sure we push frequently. We push and pull frequently. And for collaboration, we want to regularly push and pull changes. We want to code review and we want to make sure we have code reviews and pull requests. And we also have conflict prevention. We want to communicate plan changes and we want to merge frequently to reduce conflicts. And some potential pitfalls.
Yeah, we'll just kind of skip over to this for time, just because.
Well, if you go a little bit over, we can keep continuing to report if people need to leave, they
Okay,
can leave and
that's
they can
perfect.
catch the tail end of this, because this has been a very insightful presentation. I think everything you covered has been critically important for you to get, so.
Okay, perfect. Yeah, we only have like 3 or 4 slides anyways.
So take whatever time you
All
need,
right.
if people need to leave, they're welcome.
All
Okay,
right,
to finish off, we only have 5 more slides left. Going from the slides, force pushing, so potential pitfalls. It can overwrite others' work. You could use this command force with leash to mitigate risks. And rewriting shared history, you want to avoid rebasing branches others are using. Another potential pitfall is ignoring merge conflicts, which can introduce bugs and we want to always make sure we resolve conflicts carefully. There's also large commits, which is hard to review and debug. We want to we want to make sure we break into smaller manageable commits. And a scenario of a potential pitfall is losing work to force pushing without team communication.
Yeah, we want to focus on avoiding large commits again. We want to emphasize that because out in the real world, companies like Google, Microsoft, their guidelines literally include to push small changes one at a time and to never push like 200 lines of code, 300 lines of code. Some companies, yeah, they'll let you push 2,000 lines of code. They'll review it in 10 seconds and then production will break. So we're going to avoid that.
I just want to make sure we always avoid complexity. So key takeaways. Advanced Git skills enhance collaboration. It improves team efficiency and it reduces errors and conflicts. Best practices are essential. We want to prevent potential pitfalls and we want to maintain a clean and reliable code base. Continuous learning. Git is powerful. We want to make sure we keep exploring its features to make sure we succeed as a team, as a class. And a final thought, mastering Git empowers us to build better software together. We want to make sure we master Git. It's something we'll be using throughout our careers, and we want to make sure we can use Git as much and as efficient as we can.
Yeah, like for example, out in the real world, we'll use Java, TypeScript, Ruby, all these languages, but we're always gonna need to know a version control software. So keep learning this, keep developing your skills. We have some resources here in case you want to learn more. We really recommend reading over the documentation and guides. We're going to official Git documentation and along with a book recommendation. So online tutorials, I really recommend the second one, learn Git branching. A lot of those diagrams will be very familiar to you as they were from there. That's potentially what we use in order to develop an understanding that we could present. Courses and videos, YouTube channels, you can find anything on YouTube. I think we all know that by now. So keep learning, look up YouTube videos. Udemy, Coursera, they have advanced, extensive courses all the way from beginner Git all the way to super advanced Git. So that's good. That's great. And then, of course, community and support, Stack Overflow, always for questions, and the GitHub community for collaboration. So let's get into what our deliverable will be. So basically, we just want to create a simple application. Like, as you saw, we did a little calculator. It doesn't have to be anything advanced, just a few lines of code. We want to make sure that we're creating branches in order to develop features, merging branches, using rebasing. We want to create and work on a feature branch, for example, feature, whatever awesome feature you're working on. And then we're going to add this new content or features to this project in this branch. And I'm going to make at least 2 commits with clear and descriptive messages. And then we're going to go ahead and simulate changes in the main branch. We'll switch back to main. We'll make different changes that could potentially conflict with the ones we made. And then we'll commit these changes with an appropriate message. And then we'll go ahead and merge these branches while also resolving conflicts. You can read through this further, and we laid it out. So basically all you have to do is kind of follow this and you're good to go. And then you want to make sure we have an example of rebasing in there. So take use rebasing to clean up history on your feature. You can perform an interactive rebase, kind of like what we showed. So maybe drop a commit, reorder commits in a manner. And then make sure your commit history is clean and that it's logical, it's easy to read. And then go ahead, you can experiment with this, dash new committed changes. We didn't really show a tutorial, but you'll notice that if you try to switch branches while working on one, it won't let you, it'll inform you that you need to stash these changes. So make sure you do that, and then you can go to that branch, work on it, go back to the one you stashed, and then retrieve and apply those same changes and work on it more, and then eventually merge it. You can try to cherry pick a commit from another branch. And then finally, you can push your work into the repository that's created for this class. And that'll be it for the deliverable. We have YouTube, most of the tutorials go over how to accomplish this. So that would be my my advice to you. And that's it. So it's time to get going. Thank y'all. Question.
In our repository, we just put a link to it.
Yeah, you can just do that in whatever repository that Ted has made. You don't have to create a new repository, just go right in there. And that's it. Anybody has any questions? Yeah.
I guess there's a question earlier from when we were talking about stashes.
Yeah.
Are stashes saved with commits? Like, say, for example, I stash something, I go to another branch, I go back to that one, when I commit on the branch that I stashed on, is that stash saving and commit?
So basically what stashing is, yeah, you kind of just save the changes. Let me repeat the question too. So what was it again? So
I guess I'm trying to shorten it. Like, are stashes saved with
our stash is saved with the commit. So you want to stash changes prior to the commit. So basically the way it works is we make some changes and all of a sudden something broke in master. We have to go apply a hotfix. It won't let us switch, and it will tell us that we're going to be at risk of losing our changes. So all stashing will do is save those changes, and then you can go back after you've made that hotfix. You can go back into there, get those changes that you made before, and then you can afterwards you can go ahead and commit that. I'm not sure if it shows up on the repository as that. I don't believe it does. Yeah,
I would have. Yeah.
Yeah, it's-
Basically, it's kind of like, is would if anybody else that took that.
Yeah.
Was every stat.
correct me if I'm wrong, but I don't think.
Stats as well.
Yeah. So stashing, yeah. So this basically, here's our slide.
I see like we can remove stashes, so like I guess the reason I thought about that is like if you save a bunch of stashes, you apply it, you remove something.
Mhm.
All of those stashes can stay in that commit history is basically what my question is.
I'm not exactly sure on that. We didn't dive too deep into stashing because I think the main idea is you really only want to use it to just save your work and return to it later to kind of pick back up on it. I'm not sure if you want to elaborate on that.
No, I think that's a good explanation. Stashing allows you to kind of work in like a temporary workspace. And
Mhm.
then you might have to, maybe you want to go ahead and pull the most recent updated code without having to necessarily affect the repo at large.
Yeah. Yeah, exactly. So the commit history isn't really like the main idea there. It's really just about quickly saving changes and then returning to them to continue working on them.
It's also something that's a lot of these features that we went over, such as stashing, is included in GitHub Desktop. It's something you can see through the GUI. You don't have to work through the command line, but it's also important to reinforce these topics, these concepts through the command line. But a lot of it is also simplified through GitHub Desktop if you want to try that. Stashing is also in GitHub Desktop, so you can just if you want to just mess around with it, you can download it.
The use cases, I think, are very insightful here. Sometimes you'll have an instance where you want to go ahead and like publish your changes, but maybe there's other changes that are relevant. And so you might stash your changes so that you can update your local repository. And so you stash your changes so that you can do that.
Yeah.
It's just as simple as it sounds. You just save your work.
Yeah, it's definitely not as complex as the other ones where we have complex graphs to depict it or anything.
I mean, the interesting thing about Git is that you have like your local state of your repository and you have your remote state of your repository.
Yeah.
And the beautiful thing about version control, it allows you to manage those two things
Mhm.
separate.
Yeah.
I don't know.
Yeah, no problem. Cool.
Can get tools emergent conflicts?
Yeah, definitely.
That's my assumption.
That's why we want to pull often so we can avoid it. So say you're working on a file, like for example, where we created that conflict, we're adding that add method. I changed one line here, but prior to me merging, somebody else has merged a change in that file as well on that line. So when I go to git pull, if I don't pull often and I don't do that, it will definitely cause a conflict.
I know it might seem tedious, but pushing off, it's always the best choice, even if it's just like the function might seem like
I said, one more.
Yeah.
I guess this is more Git question, like when it comes to sharing the repository, but I know you said commit often, but does that also mean push often? Like,
Yeah, you do want to push as often as you can because you don't really want to create a commit when you're not really ready to push it out. Yeah, so my recommendation would be commit and push often. Any other questions? I think we're good. Thank you. We'll go ahead and stop sharing.